So this is Team Somya AI. Let us know about the team project and challenges. Over to you.
Sorry. Hi, I'm Ved and he's Rajat. We both are from IISc, previously researcher. And our project is TTS model based on LLM token predictions as an auto-regression problem. So we uh, proceed this problem mainly with two objectives. First, deployability and scalability. Second is accuracy and zero-shot cloning. So the speech LLM part is for adaptation. Like whenever you go, you learn new language, so you don't have to semantically train for new, entirely fine-tune for new languages. And sound part is global fixed part. You can just take from any reference audience. You don't need to learn that particular specific person's sound. So that's the entirety of model. In terms of novelty, we did the two-phase fine-tuning novel and the system prompt and system architecture we built on, and the new embeddings we created on Indic languages datasets. That's the entirety of our project. Results are pretty good. Let's see what happens.
Great to know about. Yeah. So great to know about your ideas. So what was the major challenges you faced in this while training or like overall pipeline?
First of all, the model size. Earlier, we are trying with 3 billion parameter model, so that was GPU constraint, and we have stability issue because in 3 billion parameter model, if you add the embeddings, it will unstabilize the entire model, and then there is a lot of missing sounds and all that. And second one is the zero-shot cloning. When you use single stream codec, it will not do the zero-shot cloning because it's learning the static sound and also. Third one was the obviously GPU training. We don't have that much resources to train on all that. So this the entire training is done like on 7 to 8 hour data set, and then that thing.
Yeah. So any other question from audience?
I would hi. I would love to know about how exactly you identify that you have to use this particular model. What was the particular use case or the problem you were and you identify and then you try to solve it using this particular model?
Okay, the initial part is like our has GPU constraint. We don't have budget to train from scratch or do things from scratch. So our first part is to take a model that are pre-trained semantically and then put our model and our embeddings on top of that part. So this is trained because it's already pre-trained on speech LLM on semantically, and then we put our embeddings on top of that and train like for 7 hours. There is no that much digital footprint because it's trained for 7 and a single node. And second part is like why I should choose this one, because earlier in round 1 we faced the zero shot cloning part. We don't have that one, so this one we add the global tokenization part also. So it will like we are speaking languages. There are two parts, content and the sound part. So say a single person can speak two multiple languages, but the sound are similar. That's the idea behind global tokenization and fixed length, because that will capture the sound and semantically will capture what to know, and then it will generate the waveform according to that part. That's the initial idea.
Right, thank you.
Yeah. Any other questions from the audience?
So, what were the major challenges you faced during training?
Can you please face the camera?
So, what were the major challenges that you faced during training?
Major challenges are first GPU constraint, second is like pipeline optimizations, and third one is like the novelty with two-phase training. We earlier, if you do the single fine-tuning training, then the embeddings will go unstabilized. For like they are not support Bhojpuri, Maithili, Gujarati, and all that. So that's the primary part. You have to extend the embeddings of model, and then first stabilize the embeddings, and then do the fine-tuning on top of that part. Earlier you were asking like why in Maithili or then how you learn what. So let's say you have this speech LLM models. It need to learn new languages, not the entire sound or speaker languages. So you can make this generate the embeddings, only train this part of that and not on the full fine tuning, just the LoRa part of it, and then put any speaker on their accent. It will speak the Maithili like the original user, not entirely, because you have to extend this one 120k or another, and it will do this. This is just for because 32, because in training it, if you do experiment with 128 or then it will do the prompt exploding. So you have like limited context window. That's one.
So, let's say you will let's say you have a greater GPU that which will allow you to train a LLM which is greater than 0.5p parameters. Okay, so in that case, can you increase your global 32 number, the 32 tokens?
Yes, definitely we can do that. Like if you, this is just because first of all this 0.5 and then is optimized or quantized heavily. But if you do like 3 billion parameter model, you can extend this context window like for not only 4K, 8K, 120K or whatever, and then you can make not only 30 seconds of reference audio, you can do 1 hour audio and it will greatly capture the entire thing because now your context window is numbered and then you can generate sound according to that.
So like how, like right now you told that you can increase the context window, right? So let's say you have increased the parameters but you have not increased the context window. So then the objective evaluation, it will differ something like with the context window also.
Yeah, it will reduce this one real time factor. It will take more time to in generation and plus the digital footprint. You need bigger GPU to generate. You can definitely build the longer context. It has a 4K, but you can 8K, 120K or any context window. But it will take a lot of time to generate even and has a lot of digital footprint as mem was criticizing. And plus there is one more thing, like it has optimized. So if you there is a nuances also. I trained with 4-bit also, but the instability of little bits and they will bifurcate and blew up the entire model. They are generating silence because it's not learning. So you have to careful with that part key, how bigger model and how you are training them.
So have you explored that option that at some point, like let's say you can increase the parameters, you can modify your constraints and all those things, but till what point you should do that so that it can be used for a helpful application?
This is helpful. This is the lowest. You can do the distillation model also. But for like longer term, you need actually audio, like studio level voice. Then you should go for 3 billion or 7 billion. For voice, you don't not go beyond 7 billion because either you have do a smart speech model that actually have a knowledge and talk, not just building text to speech, just to like knowledge question answering. Otherwise, 3 billion parameter and 7 billion upper limit, and you can go 0.1 billion parameter. But the point is, it won't learn these many languages, and the embeddings are also there.
Okay, so increasing the number of parameters, we can also increase the number of languages supported.
Yes.
Is there any relation with that?
Number of vocab size, number of token vocabulary size. This is the last layer, LM head or the weight of learning part. So the last layer that actually produce the sound, that's a vocab list. So this is depend on this one. How you train your tokenizer also.
So like how did you select your languages?
These are evaluation based on token prediction, not whatever you guys are doing here, sir. These are for token predictions, and the token has if there is a slightly more token, then it will produce much more error or word rate. So that's all.
How come the CER is more as compared to
What?
How come your CER is more as compared to dummy?
Thank you so much, Team Somya AI. So these were all the 4 teams of our. They were all the grand finalists. Let us wait for the results. Hoping for the best. All the best, teams.